Hello and welcome. I am W.R. Dudley, the host of this National Weather Service teleconference briefing. The topic of this briefing is the Pacific North American teleconnection. Let's get right into it. Introduction. So the purpose of this teleconference briefing is to educate the audience members on what the Pacific North American teleconnection, the PNA pattern is, how the PNA interacts with other teleconnections, how the PNA influences weather in the United States, and how the PNA can be used for forecasting. So a little bit about the structure of this teleconference. First, I will define what the PNA is. Second, I will establish the significance of the Pacific North American pattern. Thirdly, I will educate how the PNA interacts with the El Nino Southern Oscillation, otherwise known as ENSO. Fourth, I will educate the audience on how the PNA influences weather in the United States. And lastly, I will educate how the PNA can be used in forecasting. So what is the PNA? Wallace and Gunser in 1981 first identified the Pacific North American pattern as an area of anomalous heights, bolded here is this bold point, in the Pacific as the PNA. So at its very basic, the Pacific North American pattern is simply just an area of anomalous heights that occur in the Pacific. Further and later on, Leathers in 1991 further developed this definition and characterized it as a trough in the east central North Pacific, followed by a ridge over the Rocky Mountains and a trough over eastern North America. And if we look at figure 1 from Leathers' paper, we can see here this ridge over the western United States is underneath this solid black line, and a trough over the eastern part of the country here. So that is sort of a visual representation of what Leathers described in their paper. In addition, the PNA pattern has two distinguishing factors to it. It is characterized by a positive and a negative pattern, with a positive pattern considered the meridional flow and the zonal flow pattern as the negative pattern. We can again consult figure 1 from that paper. So the positive pattern would be indicated by this solid black line here, and the negative pattern, the dashed line, the more zonal component. So that at its most basic is the PNA pattern and the two indices of its characteristics, both positive and negative. You might be asking, what is the significance of the PNA? And there's quite a few important reasons as to why the PNA pattern is significant. First off, Justo et al. 2022, first, they described that the PNA pattern increases the fire danger across southern Asia and western North America. And when they were conducting the study, the two things they were looking at were fire weather conditions, namely precipitation and temperature. And as figure 1 showed, in the western United States, in the positive phase of the PNA pattern, there can be quite a big ridge, and with that ridge often comes higher temperatures and drier conditions. Thus, they concluded the increase in fire danger across western North America, and a similar story can be said also in southern Asia. Another point of significance of why I'm presenting on the PNA pattern and why it is important is that the PNA pattern is linked to other climate drivers like ENSO. Now, although this presentation is not about ENSO, we'll touch on it briefly later in the presentation. And because it's linked to other climate drivers, that in effect has an impact on our weather and how we can better forecast. So that's another reason of significance of the PNA pattern. In addition, the positive phase of the PNA pattern leads to well above average temperatures in the western United States and below average in the southeastern United States. Because the PNA pattern controls both temperature and precipitation to some degree, that is another reason of significance in studying the PNA pattern. In addition, the positive pattern leads to above normal precipitation in the Pacific Northwest and below average in the Midwest. So because of these far-reaching areas throughout the whole country, essentially, That is another reason why the PNA pattern is studied because of its significant ability to influence the weather in the United States. Also, using the Pacific North American pattern can help improve forecasting. Being able to identify the Pacific North American pattern and incorporate that into a forecast, that can help improve forecasting and therefore help our constituents a lot more by providing more accurate forecasts. So that is another reason why it is significant to study the PNA pattern and why it is a significant topic of conversation. So as the introduction said, we would touch on how the Pacific North American teleconnection and the El Nino Southern Oscillation connect to one another. But first, we must briefly touch on what is ENSO. At its most basic, ENSO are differences in temperature in the equatorial Pacific off the coast of America. So here we have the El Nino pattern, and this is characterized by sea surface temperatures anomaly greater than 0, as indicated by this red here. So the water temperatures, the sea surface temperatures are higher on average. And the La Nina is the opposite is true, with temperatures below average in the temperature anomalies. So that would be less than 0. So we're not going to touch too much on what ENSO is, but at its most basic, that is what it is, just differences in sea surface temperature. Now, how is the Pacific North American and ENSO connected? Well, the positive PNA pattern at the top is associated with El Nino, and Hornell and Wallace in 1981 first found this out, and it's associated with cold Pacific temperatures. If we take a look here, according to Schwaber et al. 1997, in this top figure, in the El Nino case, there is a deeper than normal Aleutian low in amplification and eastward displacement of the western Canadian ridge and negative height anomalies over the southeastern United States. This is similar to the positive phase of the PNA pattern here. On the bottom, we have the negative PNA pattern, and it is associated with the La Nina, which is associated with warmer Pacific temperatures. And once again, according to Schwaber et al. 1997, this bottom figure here essentially reveals an opposite circulation pattern associated with La Nina. This includes a weaker Aleutian low and erosion and windward displacement of the western Canadian ridge and a positive height anomaly over the southeastern United States. This is similar to the negative phase of the PNA pattern. Another study found that ENSO does not give rise to the Pacific North American teleconnection. Even though they are connected, ENSO does not give rise to it, so that means that it's not responsible for the PNA pattern. Moving forwards, how does the Pacific North American pattern influence weather? In its most essence, the Pacific North American pattern produces ridging and troughing over the western United States. So you see just above my shoulder here, in its positive phase, we do have a higher heights here. So this is inducive of a ridge. And further east, we have that trough, which will be that cooler, wetter weather to the eastern part of the United States. So that is one way how it influences weather. And in the case of the positive phase, it would influence weather because of the ridge. It will bring high pressure, so higher temperatures and dry weather can be expected in the western part of the United States. With a positive PNA pattern, with the opposite expected in the eastern part of the country, with cooler, wetter weather can be expected. In the negative phase here, that ridge moves over into the Gulf of Alaska. So this is where they'll see those higher, drier conditions. You'll see the higher temperatures and drier conditions. Whereas here on the west coast of the United States, they would more likely see wetter, colder conditions. And then on the eastern side, warmer and drier conditions associated with that ridge, high pressure. Another way the PNA pattern influences weather is that the Pacific North American pattern influences the strength and location of the East Asian jet stream, and subsequently the weather that is delivered to North America. and that was found by Graham in 2009. So by influencing the jet stream further west of us, that impacts what the weather we see here in the United States. So that is another way the Pacific North American pattern influences weather here in our country. And as I touched on earlier, the impacts it has on us, it mainly determines the large-scale weather pattern we see in our country, most notably with troughs and ridges. Lastly, Pacific North American pattern and forecasting. So as a forecaster, being able to identify Pacific North American positive and Pacific North American negative patterns is very critical to forecasting. And being able to recognize those patterns is important because if you can improve your forecast. For example, if a model is showing a positive Pacific North American pattern and it's a quite strong one, you can use that in your forecast and make calculations saying that the western part of our country will be a lot warmer and a lot drier. And this can be seen here in some of the figures here from Weather's paper. So first, looking at our February precipitation and March precipitation correlations. With the positive pattern, as mentioned earlier, that trough is going to be on the eastern side of the state. And here in quite the middle part of the eastern part of the state, we see a bullseye of higher precipitation correlation. And a similar story here in March. So being able to recognize those patterns and know that it will be wetter on the eastern side of the country and a lot drier on the western side, as both of these charts know, that is one way forecasters can improve their forecasting by knowing about the Pacific North American pattern. And a similar story can be said with temperature-wise. Here in the Pacific Northwest, temperature correlations are high, whereas down in the southeastern part of the country, they are a lot lower, and that you can kind of picture that trough and ridge pattern being responsible for that. And it's pretty much the same story in May as well, just a little bit shifted further eastward here with those higher temperature correlations in the western part of the country, and further east we have lower temperature correlations. And with longer range forecasting implications, that just comes from being able to recognize those patterns. And like I mentioned before, if model guidance is showing that we have a very prevalent Pacific North American pattern taking hold, then you can make changes to your long range forecast so that it better reflects the current state of the Pacific North American pattern. So thank you for joining this National Weather Service teleconference briefing on Pacific North American pattern. It is my hope that you can use some of this information to better your forecast and better serve our constituents here in the National Weather Service. Here's a quick look at the references I cited in this presentation. I hope you enjoyed my presentation. Thank you for watching.